Welcome to the tutorial on future value of money. After knowing the importance of time value of money, I'm sure you'll appreciate the understanding of future value. As the name itself suggests, it basically refers to cash at a particular date in future, cash or any other asset for that matter. Now, the important point to note here is that it should be equivalent to the value of a specified sum at present. Okay. Now, to illustrate this further, let's look at this timeline. On this timeline, if you see, I have projected rupees 100 in the present period and rupees 110 in the future period. For the sake of simplicity, the future period here is just one period, hence the present period. So what we are trying to say here is that rupees 110 is the future value of rupees 100 today, but the worth of 110 after one period is equal to the worth of rupees 100 today. So basically, we are saying that rupees 100 after earning an interest of 10% becomes 110 a year hence, but the worth remains the same. How to calculate the future value? Before we get into the complexities of this formula here, I would just like you to help you recall what your maths which you did in your grade 7 and 8. If you remember, you read about compound interest at your school level. Now that's the formula which you use even here to calculate the future value. If you see, the future value is represented by present value multiplied by 1 plus r within brackets to the power of n. Now here PV is 100, or PV is the present value of a specified sum, which is multiplied by the rate of interest that you're expecting on that specified sum. This r here in this illustration is 10%. It can change depending on your expectation. And n represents the number of periods of compounding. You may be probably prompted to ask why I have used the term periods and not years, because n does not represent the number of years. It represents the number of times the compounding of present value is done. For example, if the present value or rupees 100 is getting compounded 4 times in a year, the value of n becomes 4. Let's say it gets compounded 4 times in a year for a period of 4 years. So then it becomes 4 into 4, 16. Basis that, the value of n keeps changing. I hope that's clear. Let's move on to the new concept, which is called as annuity. Now, the example of annuity, first of all, is the very basic example is the pension which pensioners receive, the rent that you pay as tenants, the EMIs that you pay for a certain loan that you've taken from banks. All these are annuities. Why are they annuities? Because they are regular payments done at uniform intervals of time. Now, for an annuity, it's important for you to presume that the payment amount does not change in any period. It remains constant. We have two types of annuities: ordinary annuity and annuity due. For your purpose, we will just discuss ordinary annuity. We will not discuss annuity due in this tutorial. To calculate the future value of ordinary annuity, we take certain assumptions. The assumptions are that the rate of interest which you use to compound the annuity in the future periods, that does not change. The first payment is one period away. Please pay a lot of attention to this statement, to this assumption, which says the first payment of annuity is one period away, which means it is in period 1. It is not in period 0. That is the case in an ordinary annuity. The periodic payment does not change, which I've already discussed with you. If you see this example, it calculates the future value of annuity. For your understanding purposes, we will take ordinary annuity. We take the example of the annuity amount of rupees 100. 100 in period 1, 100 in period 2, 100 in period 3. We have taken only 3 periods. These periods can extend depending upon the situation you are in. Now, this numerical says that this annuity is earning a rate of interest of 5%. It says 0.05, which means it's earning a rate of interest of 5%. If you see this timeline, the annuity was received in period 1. Till period 3, it has 2 periods to cover, which means if you invest this annuity, the moment you receive, you will earn interest for 2 periods. That is why we have mentioned 2 here in place of n. The formula used here is the same as the formula of future value, but it has been used for different annuities in period 1, 2, and 3. In period 2, similarly, the 1 plus 0.05 has been multiplied by 1. That's because you earn interest only for one period. And in the third period, there is no interest earned by the annuity because it cannot be invested for any future periods. All these future values added up. That means 110.25 plus 105 plus 100 gives you 315.25, which is the future value of these annuities received in period 1, 2, and 3. These types of annuities are called as ordinary annuity because they have started from period 1 and then they have continued for as many number of periods. Annuity due, on the other hand, starts from period 0. We will leave this discussion here. Okay. Now, if the number of periods given here are small, these are just 2, 3, 4, 5 periods. So it's easy for you to calculate the annuity using the formula which is mentioned here, using a simple compound interest formula. In case the number of periods for which you receive annuity is high, let's say 10 years, let's say 10 periods, 20 periods, 25 periods. In that case, calculating annuity using this simple formula becomes very cumbersome. In that case, you can use the formula projected here for calculating annuity, where P is represented by periodic payment, which is annuity. P is the annuity amount. R is the rate of interest that you are earning on the annuity. And as we mentioned earlier, R should not change. R will remain uniform across your period of annuity. N is the number of periods, which may change depending upon the number of periods that you receive annuity for. And then you can insert the values in this formula and you will get the answer. This is all for now. Rest in the upcoming slides. Thank you.